Good morning to all of you. Welcome you guys. Welcome you all. How we are doing, everybody? Very good morning to all of you. I think we are live. First of all, do comment करके बोलिए now. Is the audio video is clear to everybody? Do comment करके बोलिए now. To all of you. I think we are live. First of all, do comment करके बोलिए now. Is the audio video right? Yeah. First of all, a great news to all the aspirants who are seriously preparing for 2027, 2028 के लिए. So now this Unacademy आपके लिए बढ़िया से बढ़िया ऑफर लेकर आया. So this is you will get the flat 60% of discount आपको मिलेगा. Flat 60% discount मिलेगा and इसके साथ आपका free extension भी आपको होगा. Now this Unacademy subscription that is just 8,499 rupees only. The price is going to hike soon, so utilize this opportunity before it going to expire. And you can use my personalized invite code be ready and to avail these opportunities. My personalized invite code, use it. Academy D-test. So this is the diagnostic test and which is India's biggest diagnostics test for GATE aspirants. You will with this you will get to know where you stand. Right. Yeah, very good morning. And so the exam which is on June 7th, 2 sessions, so 12:30 p.m. as well as 5 p.m. And whichever is available, you can utilize that one. That session you can plan it. And we started the new batches from May 28th onwards. नया batch शुरू हो गया. You can have a look at now here, EDC. So these are the top educators of an academy. You can find in the single frame में आपको मिलेगा. Right. So these are the GATE 2026 rankers from an academy team say. Right. ESC 2025 rankers from the different branches. There are many rankers are there. And so you can see this thing. We do offer the two types of subscriptions. One is a plus wala, other one is iconic. Plus में आपको क्या मिलेगा? Plus में आपको क्या मिलेगा? You can find it as what I'll be now here. The top educators classes मिलेगा, live doubts and test series होगा, evaluated course structured courses और PDF, live quiz, unlimited access. Iconic में आपको क्या मिलेगा? The personal coach भी मिलेगा and physical notes भी आपको मिलेगा. So you can start your preparing seriously under the guidance of your mentor. So you will get the great benefits आपको मिलेगा. Let's start serious preparation. And so this is the 7th class in the CIL series. Now I hope all of you are attending the previous all the classes and how many problems we have completed and will continue the remaining problems. How many we did? Around 100 we did, I think so. Isn't it? 110 we did. Next one. Yeah, take the next problem. The resistive network shown below is connected to a DC source of 16 volts. The power consumed by the network is 4 watts. The value of R is, yeah, you can see now here, first of all, here there is a shortage there now. So this complete current will go in this path only. Here also shortage there, complete current will flow in this path. So then this resistor, that element now here, there is no flow of current. Here there is no flow of current. Here also no flow of current. So how much the equivalent resistance you can see now here? R plus R 2R. So that is equivalent resistance. How much we have, tell me now, that is 2R. And then voltage which is given as what, I now 16 volts they given now. Now, if we asking the power consumed by the network is given, power which is equal to what I can say now, V square by R equivalent. So that is power is given as a 4, V square means 16 into 16 by R equivalent is 2R. Now we can simplify it. Now do simplify it now. So this value now 2 and this is 8, 4 and 2. So this means what we'll get now, R value equal to what here we are not getting this thing. 32 we are getting. The power consumed by the network is 4 watts. Okay. Equivalent resistance is correct only. Why we are not matching the options? Yes, resistance is 2R only, na? Yes, 2R only. So this power, how much this power is a V square by 2R, na? Power given as 4. So battery supply voltage 16 given, na? So means 16 into 16 by 2 into R. R value we don't know. Yes, 4 fourths, na? 2, 2. So this is R value which is equal 32 ohms. Okay, so this might be 32. Isn't it? 32. Next one. 2 electric bulbs rated are connected in series across 220 volt source. If 25 watt 100 watt bulbs draws power P1, P2, they asked to find the P1 and P2s. Yes, we have the two bulbs they connected now. So this is 25 and this is one bulb. This is another bulb. These two are connected in series to the source. 220 volt source they connected. Right. So if I call this is a resistance R1, this resistance is R2. Now let's find both the resistances now here. Yes, first of all, R1. How much is R1? Which is equal to V square by P now. So how much will come here? V square. So this is 220. 220 into 220 by P. P is how much now? 25. So let's get this thing here. How much will come here? 5. 5 fives. 5, 4, 5, 4. Next again 4, 4. So we have this as 44 now. So that is 44 square will come to be how much now? This resistance value, that is 1936 ohms. Next we have the resistance R2, which will be also given as V squared by P. Second bulb, they given as 220 supply, 220 into 220 by 100, and which will come to be a what element now? 22 squared now. I think 484. 484 ohms. Now these two are connected in series. They connected to a 220 voltage source. Then equivalent resistance is how much now? 1936. So equivalent resistance is what you tell me now? R equivalent series connection now. That is R1 plus R2, and which will be given as 2420. 2420 ohms. Now they ask him to find the power. Yes, now we need to find current. I can get in the circuit now. I is equal to how much now? 220 by 2420. So how much will come here? So this current, which will be equal to 0.09 amperes. Now we need to get what element now here? Power we need to get. Power across the first bulb, which will be equal to what I can say now here? I square into R1. So which will be given as I square, that is 0.09 whole square into R1, which is equal to 1936. Okay, this square into 1936. We got this is 16. We got this value 16 watts. Next P2, which is equal to I square into R2. I mean 0.09 whole square into 484. 0.09 square into 484 will come it as 3.9, like this we are getting. So it is nearly 4 watts. So see the options. P1 is 16 and P2 is 4 watts. Next, two equal resistances when connected in series to a battery consume electric power of 60 watts. If these resistances are now connected in parallel, consume the combination to the same battery, the electric power consumed is, okay. Now initially, so here two equal resistances are connected in series to a certain supply they connected. So this is R, this is also R, this is voltage is V, and the total power in this case is given as 60 they given. So what I can say now here, I current is equal to what element of V by 2R now? I1. In this case, I1. So we can get this power P1 if I call, which is given as what element of I1 square into equivalent resistance is 2R. So that is P1 will come it as I1 means V squared by 4R square into 2R. which will come to be a V square by 2R. Yes, V square by 2R. This value they given now. How much this value given? Yes, so this is P1, that is V square by 2R. This value they given us, what I know, 60 watts they given. Now, what they did now they are connected in parallel, they connected now here. So the same two resistances, now they connected in parallel. When these are connected in parallel, now in this case, parallel connected to same supply. Now this is V and this is R, this is R. If I call this current is I, this current is I1 and this current is I2. So I1 equal to V by R, V by R. So this is I value, which is what tell me now, I1 plus I2. And which will be given as what tell me? So V by R, that is 2V by R. That means power, which is nothing but we can say V into I na, that is 2V square by R. Now this is a new power. Now, so they given this as, so now the P2, so V square by R means 120, so this is 2 into 120, which will come to be a what element of 240 watts. The new power is 4 times the previous power. Next one. A current of 2 milliamperes was passed through an unknown resistor, which dissipated a power of 4.4 watts. The dissipated power when an ideal power supply of 11 volts is connected across is, okay, a current of 2 milliamperes was passed through unknown resistor. Power across this element is given as 4.4. That means power, which is equal to what I can say, tell me now, I square into R. The power which is given as 4.4, which is given as 2 milli, 2 into 10 power minus 3 whole square into R. Now, so will come it as 4.4, which is equal to 4 into 10 power minus 6 into R. So we can get this R value, that is 1.1 into 10 power 6. This is the resistance. Now what they're saying here, so when an ideal power supply of 11 volts is connected across it, now they are asking to find the power now here in this case. So when this supply is connected, so this is V square by R na, V square by R, so it will come to be a V square 11 into 11 by R. We can write as 11 into 10 power 5 we can write. So 111 will get cancelled. So 11 into 10 power minus 5 watts. Next one. In the circuit shown, the resistance R is a variable resistance, but small r equal to F into R, the heat generation in R is maximum. Then the value of R is, what will be the value of R so that we have a maximum power? Here, we need to apply the maximum power transfer theorem, MPT. Yes. So, what's the condition now here? According to MPT, for maximum power transfer, Yes, the condition is what you tell me now, RTH, which will be equal to what you tell me now here. So here load resistance must be equal to RL must be equal to RTH, we can say now. Now we need to get RTH. For this, what I can do here, we need to short the voltage sources. Voltage source is shorted, and across this element we need to calculate. We call this is A and this is B. Right. So this is also A now, and this is B. So how these two resistors parallel? So that means how much is RTH value and RTH value, which is equal to, that is R parallel will becomes R by 2. So this is, now they given small r is equal to what I will now F into capital R. So that means F is equal to how much now? 1 by 2. MPT, maximum power transfer theorem. Next, in a large building, there are 15 bulbs of 40 watts, 6 bulbs of 100 watts, 5 fans of 80 watts, and a heater 1 kilowatt. The voltage of electric mains is 220. The minimum capacity of the main fuse is how much it should be. Yes, of course, all the elements has been connected in parallel, right? And bulbs we have 15 bulbs. So yes, now here for the bulb we'll talk now here. How many bulbs are there? 15 bulbs. Each power across each bulb is given as what element of 40. And voltage is how much now? 220. Okay, 220. So from this we can get the current now here. I is equal to. So this is P by V will come to be a what element of 40 by 220. So this value now 2 and this is 11. So this is what element of 2 by 11. That means current to each bulb is 2 by 11. Okay. 15 bulbs, this wattage different of 40 watts. Now second kind of bulbs we have. How much this watt they given for 100 watts. In this case, how much will be the current, you tell me now? The current I is equal to P by V. That is what we can say 40 by V value, how much now? 100. And which will be equal to 0.4. This is the current of these bulbs. Next, fan is there. How much the fan power is? Fan power is 80 watts. So this means fan 80 watts. Only single fan is there. So the current is how much, you tell me now? So that is 80 P by V. So 80 by 220, 0 cancel. So 2 2s to 11, which will come to be a 2 by 11. Next, what else now? Heater. Heater, that is 1 kilowatt power. And how much is current, you tell me in this case now here? So this is 1000 P by V, 220 supply. So this is 50 by 11. So that means the total current for these cases, it should be given as 15 bulbs. So these are 15 now here. So we can say 15 into 2 by 11 total current. Next, plus this is how many bulbs now? 5. 5 into 0.4. plus one fan. How many fans? Five fans. 5 into 2 by 11 plus heater. So this is 1. So this is 50 by 11. These are the mains current. So how much this value, tell me. So here we have this is 30 by 11 and this value 20 means 2. This is 10 by 11 plus 50 by 11. So then how much this value, tell me now here, 90. 90 by 11 plus 2, which will come to be a 90 plus 22 by 11. So 90 plus 22 by 11. So 10 point something we have. So this is 10.18 amperes. This is the minimum current. Minimum capacity of the main fuels. So what should be taken now here? 10, more than 10 should be minimum. 12 is preferable. 10 points. So 10 is not accepted. Minimum is more than this thing. Next. Four bulbs B1, B2, B3, B4 of 100 watts each are connected to 220. So they asked him to find the mains current. So here this current will go. This current we can say this as I2. This is I3 and this is I4. And so this current we need now. If I call this current ammeter reading IA, if I call. So what is this IA, you tell me now here? Current through the second bulb I2 and this is the third bulb and next fourth bulb I4. Yeah, tell me now here. IA, which is equal to, and so this is ideal ammeter will be I2. So current is given as, so here P. So here P by V na. So this value all are same only na. So this is 100 by 220 plus 100 by 220 plus 100 by 220. So that is how much will come? 1 0 will get cancelled. So 30 by 22 will come it as 15 by 11 na? So how much this value? So little more than 1. So maybe nearly 1.35. Yes, so this value, that is 1.36 something we are getting. Next one. Two electric bulbs are connected in series to a 440 supply. Which are the bulb will fuse? Which bulb will fuse? They ask them to find. Two bulbs. Yes, now here bulb B1 if I call, the given power, this is 25 watts and 220 volts. And the resistance of this bulb, which is given as V square by R na. So will come to be how much na? V square 220 into 220 by R. R is 25. 5 fives, 5 twos, 5 twos. And this value, yes, twos now here. So how much will come this value? 22 into 22s. 484 na? Next one. And second bulb B2, they given it as 100 watts and 220 volts. Then the resistance R2, which is given as V square by R. So this R2 is V square, means 220 into 220 by 100. Yeah, we are getting same thing here also. Hmm? This value wrong. Yes, this is 220 into 220 by this is 25. How much this is? 1936 ohms. And this R2 value, how much now? 0, 0, 0, 0. Now this is 484 ohms. Now, how these two connected? Now here connected in series. They connected. Yes, which will fuse. Now we need to see when they connected in series, if the voltage is greater than the given voltage, it will get fuse. So it is connected to 440 volts. They connected. Here this is R1, which is equal to 1936. Next R2, which is equal to 484. Now, if I calculate the voltage across this resistor, this is V1 and this is V2. So, how much this V1 value? Tell me now here. 1936 by 1936 plus 484 into 440. So, how much will come? 1936 by 1936 plus 484 into 440. This voltage we are getting it as what terminal? 352 I am getting. So 352, but this capacity is 220 only. This voltage more than the rated voltage. So that's why this will get fuse. This will get damaged. Next, an electric bulb. An electric bulb is rated 220 100 watts. The power consumed by it when it is operated in 110 volts is, and we can find the rating is given now. Resistance R is equal to V square by P, which will come to be at 220 into 220 by 100. So that is R is equal to 484. Now this is connected to 110. When this connected to 110, so this means power P is equal to V square by R, which will come to be a 110 into 110 by R. R is what we have, 484. So how much will come? 25. Next one. A heater coil is cut into two equal parts, and only one part is now used in the heater. The heat generated will be, it is cut into two equal parts now here. So the resistance will decrease. R equal to, that is rho L by A. So that means now here the new resistance will becomes what you tell me now, R by 2. equal parts. Only one part is used now. So that means power P, which is equal to V square by R dash. V square initial power, if I say this as P1, so P initial power, if I call it as a P, which is equal to V square by R. Now P dash equal to V square by R dash. That is V square by R dash is what will be now here? R by 2. So this is 2 into what will come here? V square by R. That means new power which will becomes 2 times the initial power now. Now that means power is doubled. Next, the resistance of a hot tungsten filament is 10 times the coal resistance. Okay. What will be the resistance of 100 watt and 200 volt lamp when it is not used? That means cold we need now here. So the resistance power is given and then voltage given. When the resistance is in on state, that means it is a hot, which will be equal to what will be now V square by P now, which is equal to V value how much now? 200 into 200 by P, which is equal to 100. So that means when it is in on state or hot state, this is which is equal to 400 now. And they given when it is in cold, that resistance is hot by 100 now, hot by 10. So then it is 40 ohms. They asking when it is not used. Not used means cold one only. That's why 40. Next, time taken by a 836 watt heater to heat 1 liter of water from 10 degrees to 40 degrees Celsius. Okay, 836 power. Time taken. So this power we need to calculate now. So this is now electric power we have equated to thermal power. So this is P into T, and which is equal to ms delta T, thermal power. So this is, we have J is also there now, mechanical equivalent. 836 into T, which is equal to J is 1. So M value 1 liter. 1 liter means 10 cube now. CC will convert now. 10 power minus 3 into S, the specific heat of water. This is 1000. Delta T, that is 30. Change in temperature. So it will come to be a 1000. 1000 will get cancelled. So T value 30 into 4.2, if we write 4.2 into 1000 by 836. How much is value? 3 into 42 into 1000 by 836. 150 seconds. This is 150 seconds. Next, a wire when connected to a 220 volts main supply has a power dissipation P1. Now the wire is cut into two equal pieces which are connected in parallel to the same supply. The power dissipation in this case is P2. Okay, initially when they connected to 220 main supply, power dissipation is P1. P1 which is equal to what we can say now here, V square by R. Okay. Next, now this is cut into two equal parts, resistance R by 2, R by 2. Now connected in parallel. So that means R equivalent will becomes what you tell me now, R by 4. Connected to same supply. Now the new power P2 which will come to be V square by R by 4, which is equal to 4 into V square by R. Now they are asking to find the P2 by P1, which will be equal to 4 by 1. Next, if in the circuit the power dissipation is 150 watts, then R is power dissipation is 150. So you can see now these two resistors are in parallel. Will come this R equivalent, which is equal to what we have, 2R by 2 plus R. That is power P, which is equal to V square by R. P, which will be equal to 150, which is equal to V square, that is 15 square by R equivalent. R equivalent. So that is, we'll get 150 equal to 15 into 15 by R equivalent. So now you tell me what we'll get now here, 15. This is 10 times. Now this R equivalent, which is equal to 15 by 10, which is equal to 3 by 2. Now R equivalent is what, tell me now here, that is 2R by 2 plus R, which is equal to 3 by 2, which is equal to 4R, which is equal to 6 plus 3R. That means R is equal to 6 ohms. Next one. Two resistances 10 and 200 are connected in series to a battery of 4 volts with negligible internal resistance. The voltmeter is used to measure the voltage across 100 volts, which gives a reading of 1 volt. The resistance of voltmeter is, and what they given now, the two resistors 100 and 200 are connected in series. This is 100 and this is 200, and these are connected in series to a supply of 4 volts. A voltmeter used to measure the voltage across 100. Here, so here voltmeter is connected, having this voltmeter having some resistance. That resistance is R. The voltmeter reading they given as something, how much now? 1 volt is given. This voltmeter reading is 1 volt is given. If this is 1 volt, that means here this reading is 3 volts now. This reading is 3 volts. These two parallel, so we'll come it as what we can say now. Current will get current को क्या मिलेगा, कोई होगा क्या? Resistance we need to get these two parallel. So this value 100 into R by 100 plus R, and that is what you tell me now, R1. The resistance of voltmeter is, so this is V1, which will be given as R1 by, that is R1 plus 200 into 4. V1, which is 1, equal to, that is 4 R1 by R1 plus 200. We can cancel. So R1 plus 200, which is equal to 4 R1. Now we can say this as 3 R1, which is equal to 200. 3 into R1 means what? Tell me now, 100 R by, so this is 100 plus R, and which is equal to 200. So cancellation now here, this 100 will get cancelled now. So I will come it as what? Tell me now, 3R, which is equal to 200 plus 2R. That means R equal to 200 ohms. If the potential difference between B and D is 0, the value of X is potential difference between weight to weight B and D is 0. That means bridge has to be balanced. Bridge has to be balanced now here. This resistance, which is equal to 2, and this is 3, and this value, this is X by 1 plus X, and this is X. Now you tell me now ratio we have taken now here, that is 2 by X by 1 plus X, which is equal to 3 by X. We'll come it as 2 into 1 plus X by X equal to 3 by X. X cancel. 2 plus 2x equal to 3. So that is 2x is equal to 1. So x value is 1 by 2. So that means n value is 2. Next, a battery of 6 volts is connected to the current as shown in figure below. The current I drawn from the battery is balanced bridge, na? Yes, balanced bridge only. In case of balanced bridge, there is no flow now here. This is a dead element. 3, 6 and 6, 12 are parallel. Will becomes what? Tell me now. So how much is R equivalent here? So that is 6 parallel to 12. So will come to be R equivalent is 12 by 3, which is equal to 4 na. They ask him to find the current. So how much this value? Tell me now. Resistance 2 is there na. 6 by 6, which is equal to 1 ampere. Current measured by the ammeter in the reported circuit when no current flows from 10 ohm. So thus no current is flowing means what? Tell me now. Bridge balancing now. There is no effect of this thing. This is disconnected. No current is flowing. So we need to find what? Tell me now here. Balancing. This R value must be 2 ohms. They are asking to find the current now. 6 and 9 parallel na. So this is R equivalent. R equivalent is what are now 6 parallel to 9. 6 parallel to 9, which will come to be what? Tell me now. 6 into 9 by 15, which is equal to 3 2s, 3 5s. So, which will be equal to 18 by 5. So, they are asking to find the current I na, that is 36 by 18 by 5, which will be equal to 10 amperes. Yes, this current is 10 amperes. Next, two resistors 400 and 800 are connected in series across 6 volts battery. The potential difference measured by a voltmeter of 10K across 400 ohm resistor is close to. 400, 800 are connected in parallel, first thing. These, series, na? These are connected in series. 400 and 800, these are connected in series. How much is supply they given? So this is 400 and this is 800. This 6 volts. The potential difference measured by the voltmeter of 10 kilo. Here they connected this as a voltmeter having the 10K. And this voltage we need now. Calculate it. And these two parallel now here. So we can get this as V1 will come. So these two parallel, first of all, this is 400 into 10K. So here 1400. So how much is value? So 2 zeros and 2 zeros will get cancelled. Now 2 2s, 2 5 2s, and again cancel now. 2 2s, 2 6. Again, so here 2 13s will come it as what I mean 2 5000. Very small value. So this is fine. So V1 value, which will come to be a so this is 5000 by 13 by 5000 by 13 plus 800. And parallel to voltage is V, 6 volts. We can simplify now here. So how much will come this V1 value? So this is 5000 by 5000, yes, plus, so 13 into 800. This is 10,400 into 6. How much is value? 5000 into 6 by 5000 plus 10,400. So 1.9. So V1 value will come to be a 1.95. Okay. Next, 4 resistances in cyclic order to form V-store network. The resistance that has to be connected in parallel to the 10 ohm resistor to balance the network is. Now, so they given the V-stone bridge Yes, so this is what we can say now. 15, and this is what you tell me now, 12, and this is 4, and this is 10. Okay, now bridge is actually not balanced here. So they are asking to find what, tell me now here, how much additional resistance I need to connect here to be connected here, so that this will be balancing. So we can say now here 15 by 12 equal to what, tell me now here, 10R by 10 plus R by 4, balancing now. So simplify it. So here 5 threes, 5 fives. Okay, let's cancel with the 3, say will cancel. 3 fives, 3 fours. This 4 will get cancelled. So this is 5 equal to what element of here, 10R by 10 plus R. This is 5 twos. Now it is 10 plus R, which is equal to 2R. That means R is equal to 10. Next one. In a V-stone bridge, 3 resistances PQ are connected in 3 arms, and the 4th arm is formed by the 2 resistance S1 S2 are connected in parallel. The condition for bridge is what, tell me now here, P by Q, which is equal to what, tell me now, R by S1 S2 by S1 plus S2. So that is will come P by Q, which is equal to, this is R into S1 plus S2 by S1 S2. Next one. A charge Q passing through 10 ohm resistor is a function of time is given by the potential difference across the ends of the resistor at t is equal to 5 seconds is. Charge is given, potential they ask to find. Resistance is given. Okay, we'll find the current now here. Q is equal to what element of here, 3t square minus 2t plus 6. Then what it is I value, tell me now here, dq by dt will come it as 6t minus 2. At t is equal to 5 seconds is given now. We can put this I value, how much will come? 6 into 5 minus 2, that is 30 minus 2, so 28. This is the current. Now we need the potential, so V, which will be equal to, yes, 280 volts. Next. A resistance of wire is 2.5 at temperature 373 Kelvin. Okay. If the temperature coefficient of resistance of the material of the wire is 3.6, its resistance at 273 Kelvin is the variation of resistance is given as R equal to R naught into 1 plus alpha T. R, so this given, so this is 2.5, and which is R naught we have to calculate into what terminal 1 plus alpha. Alpha value 3.6 into 10 power minus 3 into Kelvin only they given. This is at 373. Yeah, we can simplify it. So we'll come it as 3.6 into 373 into 10 power minus 3 plus 1. So then it is R naught, which is equal to 2.5 by 2.34. 2.5. 1.8 like this, we are getting nearly. Okay. Next one. A conductor of length 1.5 meters and area of cross section 3 into 10 power minus 5 has electrical resistance is given. The current density in the conductor for an electric field of this much is. Okay. Electrical resistance R, which is given as what will be rho L by A. So here from this rho is equal to what I can say now R A by L. R value given how much now? So here 15 given now. Yes, A value 3 into 10 power minus 5 by L value 1.5. So we'll commit as what you tell me now here. This is tens. That is rho is equal to what, tell me now here. So 3 into 10 power minus 4. This is rho is a resistivity. And we know the relation now here. J is equal to sigma E, Ohm's law. J equal to sigma E. So we can write J is equal to 1 by rho into E. So then E value how much? 21 by rho is 3 into 10 power minus 4. 3 sevens na. So J is equal to 7 into 10 power 4. Yeah, that means what we can say 0.7 into 10 power 5 amperes per meter square. Option D. Which one? Okay, here you mean to say this is the difference. Okay. Okay, so this is 100 in that case. Yeah, now check now here. Yeah, so 3.6. So this value will come it as what will be now here, that is 2.5 by will come it as 1 point. This is 360. So will come it as what will be now here. 2 zeros will get cancelled now here. This is 3.6 into 10 power minus 1. So this is 25 by 1 plus 0.36 na. So this is R naught equal to, this is 2.5 by 1.36. Okay, which is equal to 250 by 136. So this is 250 by 136. How much now? 1.83. Yes. 1.84. Yes. So this is the answer. Next, the relation between the current, conductor and time is given as like this. The charge passing through the conductor between the times t is equal to 2 seconds to t is equal to 10 seconds is. We need to find the current charge we need to find current is given, which is equal to integral of I into dt. So that is Q is equal to integral I. So that is 12t plus 9t square into dt. So that is, which is given as from 2 to 10. So this is 12 into t squared by 2 plus 9 into t cubed by 3. Limits 0 to 2 to 10. Now 2, 6, 3 threes. So this is Q is equal to 6 into t square. So means what will be 100? 100 minus 4 plus 3 into, so this is 1000. 1000 minus 8. How much will come here? 6 into, this is 94, 96 now. 96 plus 3 into 992. Tell me how much will come finally answer. So 6 into 96. This is 576 plus 3 into 992. That is 2976. 576. 3 double. Okay, so this Q is equal to 3552 coulombs. Yes, you got the same thing. Okay. Okay, fine. Okay, yeah, that's it for today's class, and we'll meet in the next class. Okay, then, see you. Bye bye.